relationship in the data. Yes.
According to the year experience, the salary is given, sir.
According to the salary, so when you plotted
Yes, sir.
anything you find in a unique data set, is there any unique values in the data?
Yes, sir. 30,
Uh,
30 unique values are there.
30. All the 30 are unique values only. There is no repeated values, right?
No, sir.
Yeah.
Okay.
And anything else you were able to find out? So what was? Did you find any null values?
No, sir.
No. So this was just a data. So I'll show you this, people. Okay. So you have the data. Okay. So you are able to import it. So then we read the data set and displayed it. Okay. So we found out there are two columns are there named as years experience and the salary. So totally we have 30 samples in both the columns, corresponding mean, standard deviation, minimum value and maximum values and all. Okay. So mean experience is 5.3 years and an average salary is 76,000. Okay. So there are no null values if you checked out. So I need to get a count of it. So I found out that there is no null values present in the data. Okay. So I'm checking unique values. It is giving me the result. All the values as a output I'm getting it. That means there is no unique value present. Okay. All the values are unique values only. Okay. All the values present are unique values. Okay. And counts, when I checked it, so only two values which are repeating, 4 years, 4 and 3.2. Rest are like, that means this is the continuous values what we have it. All the values what we have is the continuous values. Okay. So then correspondingly if you check, okay, about the salary, the counts of the salary, is there anything repeated salaries are present? Okay. Mm, no salary is repeated for anyone. That means we found out that there are two places where the experience was repeating, but though the salary was not repeating for the same thing, like 4 years experience person, there was no same salary set. Okay, there is some variation in the salary which will happen. Okay, that actually happen in the real time also, right? So this is the histogram of the years of experience. Okay, so what is it telling is like most of the peoples are in this range of experience. Okay, so between 3 years to 6 years many peoples are present. Okay, there, because you can check here at 3 years, so there are more around 5 samples are there. Okay, then 4 years, then 5 years. Okay, so this is the area where the most of the salary so experienced candidates are present. So that is, we have 30 samples. In that 30 samples, few values are like some portion of the values are present in this particular range. Okay, the rest of the things are spread across. Okay, so instead what we have is we can have a KDE plot. Okay, kernel distribution. So that is clearly telling us, okay, so this is the area where most of the samples are present. um, and looking at the density, okay, so it is, density is not very huge here. That means the salary is present across the scale. Okay, and but more about it is more in the actually in the this particular range. Okay, so that is the inference we are able to make it from these plots. Okay, then we have one more plot which is salary years of experience versus the salary. Okay, so let me give few labeling. Okay, if you guys not tried this one, please do this one. Okay, years of experience, and y label is going to be salary, alt dot title, and behaving experience versus salary. So this is years of experience and salary. So you can see that there is a relationship between the experience and the salary. As the experience is increasing, okay, the salary of the people is also increasing, but it is not completely linear. but still it looks so somewhat more linear. Okay, so years experience too. So instead, can we have a scatter plot? Okay, instead of this, you can see we'll be able to observe the points. Otherwise, what we can do is we can put a marker here, that we can have the star marker with the red color, okay, with the dotted line connectivity. Okay, let's see. Yeah, so these are the points. Okay, yeah. So and also we can have a scatter plot here so that we can see how the data are distributed. Okay, so few samples are distributed here and few samples are scattered across this position and few are here, and it looks like level linear, the data. Okay, as the experience is increasing, your salary is also increasing. Okay, so that's the relationship we are able to make it out by looking at this data. Okay, since this was small data, we were able to do this very easily. Okay, so now I'll tell you to make a by using this relationship. Okay, if you try to build a model, okay, if you try to build a model, so which can predict the salary based upon the experience, which can try to predict the salary based upon the experience of the person. Okay, so example, if I ask you what is the salary for a 5 years experienced candidate, can you able to tell, Priya?
60,000 to 80,000, sir.
Yeah, that's the some range, but if I want some approximate value, okay, which is closest to the actual values, so I look here at your,
56
yeah,
56,000 as
yeah, so
42.
5 years experience 65,000 something, 5.1 is earning 66, 4.9 is earning 67. Okay, so then in between something value, it can be 65, it can be 67 also, right? Somewhere in the range of
Yes, sir.
65 to 68. So that is the salary we can expect for a 5 years candidate. Okay, this model will be helpful for the, so HR, like if you build that kind of model. Okay, that is the relationship between your input and the output. Okay, so here salary is based upon what? Salary is based upon your
Years of
years
experience.
experience. Okay, so now I'll come to the new point called as a regression. Okay, so now we'll discuss about regression, then by using the regression, so we'll try and out the relationship between your two variables. Okay, so now we'll discuss about regression. Okay, so regression attempts to determine the strength and character of the relationship between the one or more independent variable. Okay, so when you have only one independent variable, okay, to find the value of the dependent variable, it is called as simple linear regression. At the same time, when we have more than one independent variable, uh, variable to find value of dependent variable, it's called as multiple linear regression. Okay, so you'll be using a more than one dependent variable. Say example. Okay, so to extend this example itself, if I got some more variables, like now I have only years of experience in order to predict the salary. Okay, instead of that, okay, so in order to predict the salary, because we know that the same salary will not be given to the same experienced people. Say example, if you go to the railways, okay, the person who is having the same experience, okay, if he is a class D worker, okay, he will be having a different salaries. Okay, if a class C worker is there, he will be having another role, another level of salary. A class 1 officer will, with the same experience, will be getting a different salary, right? So class D, class C, okay, so both will be getting the different salaries with the same level of experience. Whereas class A, you cannot compare the salary of a class A 5 years experience candidate with the class D 5 years experience candidate, right? So both salaries will differ hugely with a huge margin. Okay, so then if you consider only the years of experience as a candidate to predict the salary, it fails. The model which you are going to build, the application which you are going to build, fails actually, right? But if you are using that model only for predicting the salaries of the class D employees only, the input for that particular application is only the class D employer. Okay, class D employees. Okay, in that case it will work. Okay, so but if you want to build a so generic application for the whole organization, okay, so in that case it will fail. So you need to input many parameters. Okay, so some cases the salaries are depends, okay, on the place where you are working at. Okay, so not company, and the place where you are working in. So if you are working in the location Bangalore, okay, you are working in the location Davangere, you are working in the location Shumaga. Okay, Shumaga and Davangere salaries remains the same. Okay, what about Bangalore? It changes. Okay, so look at the house prices. Okay, you want to predict the house prices in Shumaga, Davangere and Bangalore. Okay, so if you're looking at the locations there, okay, so location wise the salaries, the rents are changing. Okay, so it is not just only the, if I'm only considering the size of the home, if I'm considering only the size of the home, so then my model fails. Okay, a 30 by 40 site. Okay, so in Bangalore, okay, in the location Bangalore itself, if you find out the location, say example in Vijayanagar, which will cost you at least 10,000 rupees per square feet. Okay, so whereas in Shumaga, in some areas it will cost you less than 5,000. Okay, so even in Bangalore also, outskirts of the Bangalore, it will be, you will be getting it at just little prices. Okay, over 1,000 rupees or 2,000 rupees. Okay, so that means another factor matters there, right? So like that in certain place of examples, so many other cases also matters. Okay, if you go to the MG road, the same price, okay, say the same size of the like plot, okay, will cost you more than 25 to 30,000 rupees per square foot. Okay, so that's the differences what you'll find it. Okay, so that means more than one independent variable will be there to find the strength, to find out the required outcome. Okay, so usually when we have a, so when we have a simple linear regression, okay, so it is represented by the equation, okay, y is equal to mx plus c, y is equal to mx plus c, y is equal to m x plus c here. Okay, you know the relationship. What is this relationship? What is this? Anyone can tell? Y is equal to mx plus c is concerned. Okay, so y is equal to mx plus c represents your straight line. Okay, so y is your dependent variable and x is a independent variable. Okay, according to this term, okay, so what is y, what is y is our outcome expected, what is, and what is x plus c? Okay, so here in y is equal to mx plus c, your c is called as intercept and your mx plus c, that is m is called as your the slope. Okay, so in this, okay, so x is your independent variable, y is your dependent variable. Okay, so in some cases, okay, we can also add the residual error. Okay, residual error means the difference between the original value and the predicted value. Okay, so that will also be included in the your formula. Let us see how we are going to implement this and how it will help us in understanding this relationship between this particular example. Okay, give me a second guys, I'm just trying to open a notebook. So instead of y is equal to mx plus c, I'm using y is equal to theta 1 into x1 plus theta naught. What is theta 1 here and theta naught? Preetham? Preetham.
Don't know.
No, y is equal to mx plus c. Instead of that, I'm just replacing with this function. What is m there? I explained, no? Yeah, what is m?
Theta 1.
Yeah, m, it is Rachna?
Sir,
What is theta 1?
theta
No, so just
y
you people has given answer to the y is equal to mx plus c, right? What is the m there?
sir
What is the m?
slope
Okay. What is c?
y axis value.
M is slope and c is your intercept, right? So y is
Sir,
your,
okay, sir.
yeah, so sorry, c is your intercept and m is slope. In this we are just replacing with the that is slope is theta 1 and theta naught is what, your intercept. Okay, so yeah, so now in this, okay, what actually these two controls, what these actually means. Okay, so I'll explain that one now. Okay. Let us show here some more detailed example. Okay, first of all, okay, so I'm considering this data sheet where we have multiple independent variables in order to predict the carbon dioxide emission. This example you know it already. Okay, so in this example I'm considering one particular relationship, that is I'm considering the carbon dioxide emission. Okay, so that is y which I need to predict it. Okay, so based upon the engine size. Okay, so this is the independent variable. I'm representing this as a independent variable, one column, and this particular column I'm considering it as a dependent variable. Okay, that is the outcome which I need to predict it. Okay, so how many samples are in this example? We have 0 to 9 samples are there. Okay, so totally 10 samples. Out of that 10 sample, I don't know what is the carbon dioxide emission for the 10th sample. Okay, what is the 10th sample? Engine size is 2.4. Okay, so what should the carbon dioxide emission, if you look at this and tell me? Hello, Rachna. What is the carbon dioxide emission for 2.4 liter engine?
2 to 1.
So 2 to 1. Okay, so what about here?
Increasing, sir.
So we don't know that, so our goal is to predict this one.
If the engine,
Yeah, by looking at this data we need to make a
yes, sir.
model, and we need to do it by using the simple linear regression. Okay, so let us see how we can do that one now. Okay, so I'll just, this is not required actually, but for your basic understanding how actually the theoretical concept works, okay, I'm just giving the explanation. Okay, here, so let us say we have calculated the value of y. Okay, y is actually 250 actual value, and we calculated the y value as 340. Okay, so actual value is what, 250 carbon dioxide emission, but we calculated as 340. So in that case actually the y is supposed to be here, but because of this linear regression straight line we predicted, okay, so the y value has been changed to 340. Okay, the difference between the predicted value and the original value is called as error, residual error. What is called? Residual error. Please note down, the difference between predicted and the actual value is called as difference between predicted value and the actual value is called as residual error. Okay, so we have to try to minimize that residual error as much as possible. Okay, you can see here. So how do we, this is the error between the original value and the predicted value. Okay, so that is minus 90. Then we will calculate the MSC. Say MFC is less, then we can accept that model. Okay, so let's see how it is calculated. Okay, so take down these formulas. In order to calculate y is equal to mx plus c, or y is equal to theta 1 into x1 plus theta naught. Okay, so what is theta 1 here? You can replace this with what value? You can write it here m. Okay, so take down this formula. Theta 1 is equal to okay. Preetham?
Hello, sir.
Yes, Preetham. So what is this? X bar?
Sir, engine size.
Engine size is the X bar value. No, here what are you calculating? How do you calculate the X bar value? The
By
X,
mean.
it is a mean value. Okay, so that means you compute a sum of all the values in that particular X column and divide it by the total number of samples. Okay, similarly Y mean is also calculated. Okay, since we mentioned regression is about a supervised learning, that means for the corresponding given input, so what is the expected outcome is already given. So then we need to build a model so that for the new set of values, okay, it should be able to give the suitable results, okay, which are very much close to the actual values. Okay, so x bar y bar is calculated. We know that how to calculate theta 1. Theta 1 is equal to summation of, okay, number of samples starting with a 1 to the n. Okay, so xi minus x bar into yi minus y bar. Xi is what? The individual sample. So the first sample, then the second sample, okay, then third, fourth, and so on. Okay, so you calculate the numerator and then the denominator value. Okay, so finally compute the result of it. Okay, so all of you taken this formula, note down in your notebook. Neetu DG,
Yes, sir.
noted down the formula.
Yes, sir.
Okay, so you can roughly you can calculate it. Okay, so then we'll move on to the next slide where we have, I'll show you the calculated value. Okay, so the theta 1 calculated value is what? 39. It is 39. Fine. So then what value I need to find out again? What is the next value which is remaining? So next I need to calculate the another value. Okay, so which is theta naught. Okay, so check how we are going to calculate the theta naught. So now we are going to calculate the theta naught value. Theta naught is equal to y bar minus theta 1 into x bar. Okay, so what is the y bar value? We have the y bar value, we have the x bar value, we already have the theta 1 value. So then calculate the theta naught value. Okay, so now this is the value of theta naught. Okay, that is 125. That is the standard value we calculated. Okay, so now all of you note down these values. Sanjay,
Sir,
so what is the value of theta naught now?
125.74.
Yeah, note down that. And what is the value of theta 1 we computed?
39.
39. So using this formulas we have calculated that. Okay, so that is the intercept and the slope values we found out. Okay, so using this, so now we can calculate the any engine size you feed it. For that we can find out the carbon dioxide emission, because we have a theta naught and theta 1 value. So just you feed in the x1 value, so you'll be able to make out the y value. Okay, so now feed the engine size value as 2 liter and tell me what is the value you are going to predict carbon dioxide emission. Sanjay, substitute these two values and then take the engine size as 2.0. Then what is the output for y? It is going to be for 2 liter engine. Okay, so your theta naught is what? 125. Okay, 0.74. Okay, so theta 1 into x. Okay, 2 into 39. Okay,
203.74.
plus 125.74. Okay, 203. Is it very close to the actual value 196? Is it close or not? Okay, so the difference between the 203 and the 196 is how much? 7. Okay, so you can ignore it, right? So if you are okay with that, you can consider. So that difference is called as a residual error. What is the difference is called as? Sanjay?
Sir, residual error.
Residual error. How do you calculate the residual error?
By using
The difference between predicted value and the actual value. Okay, so this is the ground truth, right, which we have provided. Okay, say consider like if you are now we are going to replace here with the salary and the years of experience. So we already have the salary values here and the years of experience. Okay, so based upon that we need, our goal is to predict the salaries. Okay, so then you predict some value of the salary, the predicted value of the salary, the difference between the predicted value and the ground truth. So that is we call as a residual error. Okay, so whether no matter what is the, so here the theta 1 theta will be now calculated for the carbon dioxide emission. So then we are going to use the same model for our salary and the experience model. So these are the formulas basically used in order to calculate the linear regression model, simple linear regression model. Okay, where we have only one dependent variable. Okay, so if you get more than one dependent variable, so what else you'll, the formula extends like this. Okay, so y is equal to theta naught plus theta 1 into x, right? So that will get extended. So that will get extended. Okay, to a new level. Okay, so what is the new level? So if you have more than one input variables, okay, then you can write it as a, so theta 1 into x1 plus theta 2 into x2, theta 3 into x3 and so on. Okay, so that is when you use a more than one independent variables. Okay, so let us try this now. Okay guys, okay, so which I already given it, the program part, the simple linear regression. Okay, so here in my data set, okay, that is data.head, so which one is theta 1 and which one is theta 2 here? So theta naught and theta 1. What are the values of theta naught and theta 1 here? Theta naught is yours. What is theta naught value? So you need to calculate it by substituting the y and your x value. Okay. So what is the x value here? X value is salary and y value is your years of experience. Okay. So instead, like for this calculation, we will not go with the manual method. So I have shown the one example of using the manual method. Okay. So basically what it tells is, so to find the relationship between the one independent variable with the another dependent variable, okay, or more dependent variables to predict the value of the one particular dependent variable. Okay. So but the main assumption is here the data is linear. Okay. So now how do we do it here in Python? The same thing. Okay, using a suitable library we can do this. Okay, using a suitable libraries we can develop this particular project. Okay, which we can actually do the this linear regression analysis. Okay, whether it can be simple linear or it can be a multiple linear regression. So few points to note down. MSE, mean squared error, measures the prediction errors. Okay, it measures the prediction error. So it is the difference between, okay, so instead of MSE we'll be using the RMSE. Okay, already shown the formula in order to calculate the mean squared error. Okay, so it basically predicts the measures the prediction error. So what you will be having it. So now we'll see how we'll do this calculation step by step. So split this y, split the x. Okay. So what is the y column? Y is equal to, how do you separate it? How do we separate it? I want to read only the y values. How to read only the y values? Sheetal, how to read only the y values? Data dot.
Yes, sir.
How to read only the y values? Data dot years of experience, right?
Yes, sir.
So you can take years experience. Okay. So you don't require a inverted quote here when you're writing like that. So this is equal to data dot salary. So we are just splitting the two variables. Okay, so just trying to print y comma x, making sure that we have splitted those two variables, right? So in order to calculate this way. Okay, so we need to be splitting those two values. Now y has been printed and x has been also be x is y comma x. So this is y values and the x values have been printed here. Okay, so let us move on to the next. I'll try to put both of them in new one, but no, still it is going to next value. Okay, no issues. Anyways, they have been splitted, the values has been splitted now. So what is the next step? Okay, so now in order to build a linear regression model, okay, so we can use a specialized library we can use. Okay, so that is called as scikit learn. Okay, so basically it is a scientific kit library, okay, so provides most of the tools required for the data science and machine learning. We already seen that, right? So it will be useful for regression, classification, and I shown that website in the previous week. Okay, so one thing you need to remember when you want to build any machine learning model, in order to build a good ML model, okay, so we need to test the model performance after building the model. First we need to build the model, then we need to check for its performance, okay, how it is performing. Okay, so if its performance is better, then what we can do is we can keep that model, otherwise we need to do some modification. Okay, so how you are going to test the model? Mantesh, ಈಗ ನೋಡಿ ಇಲ್ಲಿ ಎಷ್ಟು ಸ್ಯಾಂಪಲ್ಸ್ ಇದೆ ಈ ಡೇಟಾದಲ್ಲಿ? ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಎಕ್ಸಾಂಪಲ್ ಈ ಎಕ್ಸಾಂಪಲ್ ಎಷ್ಟಿದೆ ರೀ ಸ್ಯಾಂಪಲ್ಸ್? 0 to
total 9 sir.
9 ಸ್ಯಾಂಪಲ್ಸ್ ಇದೆ. 0 to 8 9 ಸ್ಯಾಂಪಲ್ಸ್ ಇದೆಯಲ್ಲ. ಈಗ 9 ವ್ಯಾಲ್ಯೂಸನ್ನು ಪಾಸ್ ಮಾಡಿದೀವಲ್ವಾ ಇಲ್ಲಿ y ವ್ಯಾಲ್ಯೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ. So ಇಲ್ಲಿ ಯೂಸ್ ಮಾಡಿದ್ವಿ all the 9 values we used and we did the similar approach we will be using it in this code. Okay, ಈ ಕೋಡ್ ಅಲ್ಲಿ ಎಷ್ಟು ಸ್ಯಾಂಪಲ್ಸ್ ಯೂಸ್ ಮಾಡ್ತೀರಾ? 30 ಸ್ಯಾಂಪಲ್ಸ್ ಇದೆಯಲ್ವಾ 0 to 30. ಎಲ್ಲ ಸ್ಯಾಂಪಲ್ಸ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಟೆಸ್ಟಿಂಗ್ ಹೆಂಗೆ ಮಾಡ್ತೀರಾ ಅಂದರೆ ಇದು ಟೆಸ್ಟಿಂಗ್ ಅಂದರೆ ಒಂದು ಅನ್ನೋನ್ ಸ್ಯಾಂಪಲ್ಸ್ ಕೊಡಬೇಕು, ಅದಕ್ಕೆ ಯಾವ ಥರ ರಿಸಲ್ಟ್ ಬರ್ತಿದೆ ಅಂತ ಚೆಕ್ ಮಾಡಬೇಕು ಅಲ್ವಾ? ಸೊ ಪ್ರೀವಿಯಸ್ಲಿ ವಿ ಟೆಸ್ಟೆಡ್ ಇನ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಎಕ್ಸಾಂಪಲ್ ಇಟ್ ವಾಸ್ ಗಿವಿಂಗ್ ವಾಸ್ ದ ಕ್ಲೋಸ್ ರಿಲೇಶನ್ಶಿಪ್, ಬಟ್ ಚೆಕಿಂಗ್ ಓನ್ಲಿ ವಿತ್ ದ ಒನ್ ವ್ಯಾಲ್ಯೂ ವಿಲ್ ಇಟ್ ಹೆಲ್ಪ್ಫುಲ್? No, right? So we need to check with the multiple values like how it is performing and all. Okay, so for that purpose what we need to do is we need to split our data into training set and the test set. That means, so when I want to build this model, okay, y is equal to mx plus c or y is equal to theta 1x into x1 plus theta naught, okay, so I need to make sure that it works for the some unknown samples which are not part of this data. Okay, so that is the model evaluation, we call that as a model evaluation. Okay, yeah, so let me show that. Okay, so model evaluation approaches. So there are two approaches are there. One is train test on the same data set and one more is train test split. Okay, note down. So there are two procedures for model evaluation. One is train test on the same data set and one more is train test split. Train test split. Okay, in a train and test on the same data set, in the train test on the same data set, the approach is train the model on the same data set and take few samples from this and test it. Okay, so then what happens? Example ಈಗ ನವೇಶ್ರೀ,
Yes, sir.
ಈಗ ನಿಮಗೆ ನಾನು ನಿಮಗೆ ಕ್ಲಾಸಲ್ಲಿ 10 ಕ್ವಶನ್ಸ್ ಕೊಟ್ಟಿರ್ತೀನಿ ನಿಮಗೆ.
Okay, sir.
ಎಕ್ಸಾಂಪಲ್ ನನ್ನ ಹತ್ರ 10 ಕ್ವಶನ್ಸ್ ಇದೆ. ಓಕೆ, ಆ 10 ಕ್ವಶನ್ಸ್ ಮೇಲೂ ನಿಮ್ಮನ್ನ ಪ್ರಿಪೇರ್ ಮಾಡಿಸಿರ್ತೀನಿ ನಾನು. ಓಕೆ,
Yes.
I have 10 questions. I prepared you on all the 10 questions. If I ask a fifth question, okay, will you be giving me good answer or not?
We will give, sir.
Definitely. Okay.
Yes, sir.
So what about the seventh question? You will definitely you will give the answer, right? But
Yes, sir.
what if instead of, okay, so out of 1 to 10 questions, I given you all the questions, okay, and you prepared for all the 10 questions. If I ask any of the questions inside that, you will definitely answer it, right?
Yes, sir.
Instead, out of 1 to 10 questions, I given you 7 questions only. To prepare for yourself, okay, and I skipped giving you second question, sixth question, and the eighth question. I not given you these 3 questions. So that makes it 7 questions, right?
Yes, sir.
Out of 10 questions, I given you only 7 questions. I not given you the second, sixth, and eighth question. Okay, but all the questions are from same unit only. Okay. So now in the interview, in the test, I asked you the fifth question, sixth question, seventh question, and the eighth question. 4 questions I asked you. Okay. So how do you answer it there?
Sir, if I only prepared questions, I used to answer, sir.
So fifth question, sixth question, seventh question, eighth question. See, if you understood the concept very well, by practicing that 7 questions, okay, practicing all the 7 questions, you can answer all the 4 questions. That is, you can answer to the 5th question. 6th question is unknown question, but still if you are answering it, so then I can consider that you are understanding the concept. Rather than just mugging the questions, you are actually understanding the concepts and you are prepared. Okay. Otherwise, if you are performing very well to the 5th question and you are giving very good explanation to the 7th question, but if you are failing to meet the 7th, 6th, and 8th question, okay, so then what should I consider? I should consider that you are not learning, you are not putting effort. That means you are not going to the details and you are able to understand it. Okay, so this is the same thing. Okay, giving all the 10 questions, okay, asking few questions from that is called as training and testing on the same data. Okay, training and testing on the same data. 1 minute, guys. Training and testing on the same data set. Understood what is training and test on the same data set? So what is the advantage of training and test set? So you will be having a higher training accuracy and higher test accuracy. ನೀವು ಇಂಟರ್ನಲ್ಲೂ ಚೆನ್ನಾಗಿ ಸ್ಕೋರ್ ಮಾಡ್ತೀರಾ, ಎಕ್ಸ್ಟರ್ನಲ್ಲೂ ಚೆನ್ನಾಗಿ ಸ್ಕೋರ್ ಮಾಡ್ತೀರಾ. ಯಾಕಂದರೆ ಅದೇ 10 ಕ್ವಶನ್ಸಿಂದ ಇಂಟರ್ನಲ್ ಕ್ವಶನ್ಸ್ ಕೊಟ್ಟು ಎಕ್ಸ್ಟರ್ನಲ್ಲೂ ಅದೇ 10 ಕ್ವಶನ್ಸಿಂದ ಕ್ವಶನ್ಸ್ ಕೊಟ್ಟರೆ ನೀವು ಚೆನ್ನಾಗಿ ಆನ್ಸರ್ ಮಾಡೇ ಮಾಡ್ತೀರಾ. ಓಕೆ, ಸೊ ದಟ್ ಮೀನ್ಸ್, ಸೊ ಬಟ್ ದ ಪ್ರಾಬ್ಲಮ್ ವಿತ್ ದಟ್ ಈಸ್ ವಾಟ್? You are not generalized to answer all the questions. You are not generalized to answer some unknown questions. Clear? What is the meaning of train and test on the same data set? Okay. So then we use another approach. That is called as a train test split. Okay. So what I'll do is, okay, so I will take this data set. Okay, I will take your data set. Okay, I'll split your data set into out of 10 questions, 70% of the questions, okay, so will be used for training and 30% will be used for testing. Okay, so if your performance is good in both the cases, okay, so then I will consider you are performing better. then I can use that model, okay, because your training accuracy is also good, okay, testing accuracy is also good, okay. In that case we can consider you as a fit student, okay, who has the best understanding of the concept. Otherwise I will not be considering you, okay. So that is the difference, okay, what happens in the train test bit, okay. So how about taking a 40% data for testing training, okay, 60% of the data for the testing. ಈ ಕೇಸಲ್ಲಿ ಏನಾಗುತ್ತೆ ಲಕ್ಷ್ಮಿ?
So accuracy will not be good.
ಈಗ ನಾನು ನಿಮಗೆ ಕ್ವಶನ್ಸ್ ಕೊಟ್ಟಿರೋದೇ ಕಡಿಮೆ ಕೊಟ್ಟಿದ್ದೀನಿ. ದಟ್ ಮೀನ್ಸ್ ಐ ಔಟ್ ಆಫ್ 6 units, out of 10 units, I teach only 4 units. It is like I teach you only the 4 units, okay. I'll consider 1 unit. In that I only covered 40% of the portion, okay. But I'm asking you the questions in the rest 60%. Can we expect a good answer from you? No, right?
No, sir.
We cannot expect it. At least if I covered 50 to 60% of the portion, okay, then I am asking you to answer from the 40 and 50% of the questions will be unknown questions. Then still if you are performing better, so then I can consider you as a good model, good student, okay. At least the portion you expect is ನೀವು ಹಾಗೆ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ತೀರಲ್ಲ, at least 50% of portion cover ಆಗಿರಬೇಕು. But most of the cases, will you expect 50%? No, at least 70% is what expected, right? In general, okay. So when we want to split the data set to training and test, okay, 70% for training is the standard used and 30% is the test, okay. So most of the cases 80:20. So this is what used, training purpose and test purpose. If the data set is very large, if the portion is very lengthier, okay, you have 20 units to be covered. In that case 70:30 will work better, okay. If there are 100 units or if there are 100 different questions, okay, or thousands of questions, in that case if I have a thousands of questions from a one unit, so then can you expect there is a variations in the questions you can find out? No, right? So which will be very much similar with a different meaning, different way of asking the same questions might be there, okay. In that case you can work with a 50-50, okay. So this is used when there is a large quantity of the data, okay, or very small quantity of the data. In that case we go for 90:10 also, okay. So that is a split, we will be doing it on our data set. Clear? Why we need to do this splitting the data? For the model evaluation purpose, okay. For the model evaluation purpose we will be splitting our data into training set and test set, okay. So one more approach is train test on same data, okay, which is not good. So same data you take it, split it into training set and test set, okay. So that is the best approach we will be having it, okay. So what is the advantage of training and test set splitting? So training accuracy will be good sometimes, okay, good or moderate, okay. Test set good, or it can be moderate, or it can be less, okay. But when it is less we can retrain our model and increase it, okay. In train set what happens is always higher model accuracy, model training accuracy, and higher test accuracy. But the problem is not generalized model, okay. So what is the meaning of generalized model? So a model which can work for any kind of data which are like similar, related to that particular application, okay. So you will be getting a generalized model. Our intention is always should be building a generalized model, okay. So example, I am building a model to predict the it is to recognize whether given input image is a cat or a dog. Okay, in that case, if I'm using only the data set of a few species of the, okay, few variants of the dog variations, like I'll give Labrador, I'll give Cocker Spaniel, I'll give maybe like Indian breed, okay, and then I'll give, okay, a bulldog, okay, like that 4 to 5 variants if I give it, okay. So then all of a sudden I'll give the another variant of the dog variations, okay. So that is a Doberman if I give it, okay. So if it is able to recognize that, then I can call it as a generalized model, okay. Or if there is a variation in the color with the same Labrador, okay, if it is able to recognize that, then I can call it as a generalized model. Or then if it fails to recognize instead of dog as a cat, okay, then it is a failed model, okay. So all these cases will be using a training and test splitting, okay. So this is the best method used for building your all machine learning models, whether you are doing a regression analysis or a classification. So train, test on a same data set. This is the total data set you have it. Train on full data set. Take some portion to test it. Okay. So training and test on the same data set. This is what happens. Okay. You get a high training accuracy, low out of sample accuracy. That it means, okay. So it will have a lower accuracy on an unknown sample. Lower accuracy on a unknown data set. Okay. So training and set on a training test split evaluation. Okay, what happens is, in this case, entire data set, in that some portion of the data set is used for training and some other portion is used for the testing. Okay, so in this case we can have a better accuracies in both the cases. Okay, and model accuracy or out of sample is very good. Okay, out of sample accuracy is very good. Okay, so here low out of sample accuracy, high training accuracy. Okay, so mutually exclusive means higher training set accuracy, higher test accuracy also. So please note down this point. Okay, then we'll move on to building our model now. Note it down, guys. Take a snapshot of this, all of you. Take the snapshot of this. Rachna,
Yes, sir.
done? Taken the snapshot?
Yes, sir.
Okay, guys,
Yes,
then
sir.
I'll move on quickly because I have another session. So let us start doing actually the main coding part. Okay. So as we mentioned, I already splitted your data into 2 sets. What is that? Values I have splitted here, right? X and Y. Okay. So let us continue it from here. So I'm going to split my data set. For that I'll be using sklearn dot model underscore selection import train underscore test underscore split method. Okay, so this is the function I'll be using it. For this I'm using see, instead of y and x, let me take it as a dependent variable so that it will become easy for you people to understand. Then independent variable. Okay, so I imported this library called as train test split. Okay, so once you import it, okay, please try this code in your, whether it works or not. dpn comma ind dependent and independent variables. Okay, So now moving on to the next step. So dependent underscore train dependent underscore test data, comma independent underscore train, comma independent underscore test is equal to, okay, is equal to the same function. Okay, so let's guess, I don't want to print it. Let us try this. Let me try it here only. Train test split of independent variable comma dependent variable, both I am trying to split it. Okay, so what is this, how much you want to have a independent, what is the ratio you would like to split it? Okay, so you just need to mention the test size, test underscore size is equal to 0.25. that means 25% of the samples are used for testing. Okay, so the remaining samples are used for the training purpose. Okay, so that's it. So we have done the splitting of your data. Okay, we're able to split your data. So then if you check the length of your dependent training sample, okay, 22 samples out of 30 samples, 22 samples are used for training purpose. Okay, and remaining 8 samples are used for the testing purpose. Is that clear what we are doing it here? So let me share this code. Okay, so now let us complete it, guys. This much. Shashank,
Yes, sir.
completed.
Yes, sir. Completed.
Split ಆಗಿದೆನಾ ಈ ರಿಸಲ್ಟ್ ಬರ್ತಿದೆನಾ 22 ಸ್ಯಾಂಪಲ್ಸ್ ಅಂತಂದು?
Yes, sir.
Okay, so now let us build the linear regression model. Okay, how do we are going to build it? So it's very simple. The theoretically I shown you, like there are many equations and all, so we are not going to write an algorithm to build that. So we will be using the scikit library, okay, which provides us the linear regression method. Okay, for that import from sklearn dot linear underscore model import linear regression. Okay, import linear regression. Okay, so then create an object called as LR that is equal to linear regression. Okay, so once you have created, okay, just you need to use the LR dot fit method. Okay, so this method now will fit the data onto the straight line or computes the linear regression of independent variable with respect to dependent variable. Sorry, it is dependent variable with respect to independent variable. So what do you need to pass on? So should I pass here dependent or independent or a training data only? Priya?
Sir,
Should I pass the independent and dependent variable both directly or only the training set of the dependent and independent variable?
training.
Only the training set. Okay, so just I'm trying to build that a linear regression model with the help of dependent variable and the independent variable. So dependent variable, so independent variable comma dependent variable, it is always okay. So this is the method so which we have done once. 1 minute. Independent variable lr dot fit linear regression where is the error? Reshape your data either using array shape -1 comma 1. Okay, so actually there is some issue regarding this data we are passing it. Okay, the problem is when we use this kind of method in order to for a ML models, okay, they don't accept it. Okay, so because if you check the shape of this, it is a little bit different. Okay. Or DPN, give me a minute guys. Okay, so when I give it is a single row. Okay, so this kind of inputs are not accepted. Okay, it is 30 comma 1, it should be 2-dimensional, even though it is having a only one column of data, but it should be a 2-column data. It should represent it as a 2-column data. So let's see how we can do that conversion. Okay, let us, in order to get that, okay, let us try changing this. Okay, data dot, okay, index I log all the rows comma 0th column to the 1st column. Okay, let me read it. Okay, and check it. So let me check the shape of it. Now it is 30 comma 1. Okay, in the both the cases it is having the same number of samples and outcome. Okay, but this method will make it to 1:2. One minute. This is iLock. So now the shape has been changed to 30 comma 1 instead of just a 30. Okay, so now if I try this model, see, it works, no issues at all. Okay, so for all ML models, make sure that your shapes are not just samples. Okay, instead they should be if you're having only one row or a column, make sure that it will be using it has to be reshaped. Okay, for that purpose I'm using this one. Okay, so if you get more doubts on this one, you can ask me this question in the tomorrow class, guys. Okay, now lr.fit method is the one which is used. Okay, I'll explain this again regression problem in tomorrow class once again. Okay, so now let me show you, this is a fitted method. Okay, now my data has been fitted onto this. Okay, so let us see how this works. Okay, now I'm trying to predict the new prediction on a new data set. Okay, so lr dot predict of, which is the unknown samples here, Priya, which are not trained here. Dependent test is the outcome. Okay, independent test is the corresponding input, right? So if I pass this independent test data here to the prediction function, okay, so it is the new values which has been predicted, right, for that particular
Yes, sir.
data set. Okay, So now these are the values of that. Okay, so let me show you something. Okay, I am going to now plot dependent underscore test. So these are actually original salaries 46,205. Okay, is the original salary, but what is the predicted salary is 36,259. Original salary is 1,16,000, 1,14,000, very close value. 1,01,000, 99,000, closest value. 64,000, 54,000, not very close. 1,09,000, 1,07,000, very close value. 57, 59, very close value. So that means these are the predicted values and these are actual values. Okay, for these salary columns. Okay, what are the salary columns we had? So the experiences, okay, that is present inside this independent test value. Okay, if you like to see that independent test value, you can see them 1.3, 9.5, 7.9, 8.7, 3. These are the experiences. Okay, so these are the corresponding original salaries, and this is what our model has been predicted. Okay, and you could see that, so most of the cases it has predicted the very closest value. Okay, so this is the model which I can use it. Okay, if you are happy with this one, okay, we can use this model to predict the salaries of any persons with his experience. Okay, the HR can predict easily what should be the salary to be set. Okay, so based upon this application. Yes. So yes guys, have any question? We will continue again this from tomorrow, the same example, and I'll do the plotting and all, then we can see how this like if you get any doubts and all, you can ask me in the tomorrow session again. Okay.